All right, here are the answers to the rest of the worksheet. So hopefully you've been working a few on your own and then checking your answers. So again, you might want to try this one on your own and then pause it, or do several and then pause it and see, and then go check your answers. Which expression is equivalent to this lovely thing here? So I'll look at the answers and they all look like these are multiplication problems. So I'm thinking if I just multiply the answers, it should equal that, which I think would work. So my first piece is a negative 56x squared. So if I multiply negative 8 times 7, I get negative 56. And x times x is x squared, so I'm going to keep that one. Now if you want to check the second piece, it's a positive 32x. When I multiply negative times positive, I get a negative 32, so I'm going to cross that one off right there before I go any further. This is a positive times a positive, so this is a positive 56. Do I want positive 56? Nope, don't even worry about the x's. All right, I want a negative times a positive gives me a negative 56, and it is x times x, so that is x squared. Check the box on the first one, yep. Then negative times negative is a positive 32, and again, put all this math in the calculator, just the plain old numbers being multiplied. So whenever you're doing this distribution, you are multiplying. So that gave me a positive 32, and I have a single x here, but no x's here, so a single x in the answer. Is that what I wanted it to be? It is. I'm thinking it's B. If you want to check the last one to be sure, this was a negative 56x squared, but negative times positive gave you another negative 32, which I don't want. So B was the correct answer. Which expression is a factor of this thing? Normally the answers give us two sets of factors here, and we multiply them together to get the answer. So one way of doing these is to take each answer and multiply them and work them backwards. However, the problem with this is they're only asking you to find a single factor, so they're only giving me a single factor. So I don't have two things to multiply. I can't do this one backwards. You're going to have to just factor this totally by hand. Now, normally when we're trying to come up with this, we look for GCF first. And there's only a 1 and 144, so nothing will go evenly into 1 except 1, so there is no GCF, and there were no x's in both of them, so again, no GCF. So step 2 is to try to factor it into a binomial times a binomial. Well, normally when we do that, this thing is 3 pieces up here, a trinomial. What am I missing? I have an x squared, I have a plain number, I'm missing the middle piece, so rewrite it with all 3 pieces. This is x squared, that means the middle piece is a 0x, because 0 times x is 0, it goes away, minus 144. I can factor this because now I have all 3 pieces, and I know the add subtract number in the middle. So it's going to be an x times an x, and then I make a list of these factors. It's 1 times 144. It can be 2 times something. I think that's what, 72. 3, maybe 3 goes evenly into it. Maybe 4 goes evenly into it. There's probably a whole bunch of numbers that go evenly into that. So I'm trying to think if there's a way that I can shortcut this big long list of numbers. One, you could look over here and say, well, I think I could try a 12, and I could try a 9 and a 6, and then there's 9 again. So all I really need to try is 6, 12, and 9. So there's not a 6 in this, not a 12 in those. So I might just go say 6 times what is 144? 9, 6, and 9 and 12. So 9 times what is 144? So there's I need a 6 times something, a 9 times something. What's the other one? 12 times something. So if you take 144 divided by 6, put the number here. Take 144 divided by 9, put the number there. Take 144 divided by 12, put the number here. And those of you that are thinking, ooh, I need this to be a 0, so these two numbers need to be the same. 12 times 12 gives me 144, but if I subtract them, don't I get a 0? Yes, if I have two numbers here, like, I don't even know what these are, 6, I forgot what the numbers are, I should have written them down someplace. But 6 times something is 144, but if I add them together, I'm not going to get 0, and if I subtract them, I'm not going to get 0 because they're not the same numbers. So I'm thinking it's 12 and 12, and you would be right because those are my perfect squares. Now, one needs to be positive, one needs to be negative. So if I multiply them together, do you get a negative 144? Yes. If I add them together, do you get a 0? Yes. So I need an x plus 12 and an x minus 12. So x plus 12 and x minus 12. Is that one of the answers over here? Yes, it is. It is B right there. All right, so the key to these is when you don't have the full trinomial, make the whole trinomial, and then you're looking for some number that gives you a 0, which means the two numbers need to be the same number, and one's going to be positive, one's going to be negative. Okay, which expression is equivalent to this lovely thing? Now, you might want to go back and look at your perfect squares. 12 times 12 is 144, 13 times 13 is 169, 14 times 14 is 196, and 15 times 15 is 225. That might save you some time if you know your perfect squares. If not, use your calculator and do 13 times 13, 14 times 14, so on. Which expression is equivalent to this lovely thing? So I like look at the answers. They're multiplying binomials together, and then there's one that says none of these. So I can either multiply all these answers together and see if I get this, or you could just go factor it by hand. If you're good at factoring it by hand and there is no GCF in this, so you're just going to do the slide and divide technique, go do that and see what the answer is. If you want to multiply them by hand, let's go do that. 2x times x is 2x squared, 2x times x is 2x squared, 2x times x. Every one of them gives me the first piece, but the last piece is a 7. Negative times positive is a -7, and that's not my number, so cross it off. This one is positive times positive. It gives me a +7, so I'm going to keep that one. And this one is a -10 times a -1, which gives me a +10. Is that my number on the end? No. So it's either none of these or it's this one. So I'm just going to go ahead and multiply this together and see if I get that. Those of you that are doing the just factoring by hand, just go ahead and factor it by hand. But if you want to multiply the answers together, 2x times x is 2x squared. 2x times 1 is +2x. And then come back and do 7 times x and get a +7x. And then 7 times 1 gives you a +7. These two are the middle ones that go together, so this is a 9x. So this is 2x squared plus 9x plus 7. Do I have a +9x in the middle? I do not, so it is not that answer. So what's it going to be? None of these. If you tried to factor this one by hand, none of the combinations that you could come up with the positive and negative numbers worked. None of it worked. It was not factorable. What is a factor of this thing? So again, they're just giving you a single factor, not both of them, so I can't multiply the answers together. I have to go factor this by hand. The good news is there's only a 1 in front of the x squared, so you don't have to do slide and divide. And there is no GCF because there's no x's in all three pieces, and that's a 1, and 1 only goes into 1. So we're just going to go factor this. It is hopefully a binomial times a binomial, so it's going to be x times x at the beginning to give me the x squared. And these two numbers multiplied together have to equal 27, so let's make a list. 1 times 27. 2 will not go evenly. 3 times 9. 4 will not go evenly. 5 will not go evenly. 6 will not go evenly. 7 will not go evenly. 8 will not go evenly. And 9 we've already used. So the only choices are 1 times 27 and 3 and 9. The middle number is a 6. So which one should we use? You're right. If I subtract these, I get a 6. And I want a +6, so I'm going to make the 9 the positive and the 3 the negative. And again, just try every combination of positive and negative numbers and add them in the calculator and see if you get a +6. So I want the -3 and +9, because if I add them together, I get a +6. If I multiply them together, they need to equal -27, which they do. So I have x minus 3 and x plus 9. Now, that is now factored, so I just need to pick it out. Is that x minus 3 or x plus 9? Oh, there's the x plus 9, so it's this one. Double check there's not any others. X plus 1, nope. X plus 3, nope. So that was the winner there, number C, or the letter C. 11, simplify this thing. And when I look at this, there's no pluses or minuses between this, so this is not addition or subtraction. It is multiplication. And this is a binomial, so it's a double distribution. It's this times this, and then that times that, and that times that, and then come back and do this one times that one, this one times that one, this one times the third one. So do them one at a time. Multiplying, you multiply the big coefficients, add the exponents. 2 times 3 is 6. X cubed times x squared, you add them, that's x to the 5th. 2x times the next piece. 2 times -4 is a -8. X to the 3rd times a single x is x to the 4th. And then take this times the last piece. 2 times a +6 is a +12. And x cubed times no x's is still x cubed. Then come back and do the 3. +3 times +3 is +9. And x squared is the only x's in these two pieces, so I say x squared. Then 3 times the -4 gives me a -12. No x's times a single x means I still have a single x. And 3 times a +6 gives me a +18. Are there any like terms? X to the 5th, x to the 4th, x to the 3rd, x squared, x, and a number. No, so that whole answer is your final answer. There were no like terms to combine. Factor this. No multiple choice, we just got to factor this thing by hand. So I'm thinking GCF first. Are there x's in all three pieces? No. Is there any number that will go evenly into 5, 18, and 9? The only thing that goes evenly into 5 other than 1 is 5, and 5 won't go into 18, and 5 won't go into 9. So nope, no GCF, but we checked it. So I want to factor this into a binomial times a binomial, but I cannot do it with the 5 sitting here. So what are you going to use? Slide and divide technique. So we're going to multiply this over here, and at the end I need to remember to divide by 5 because I'm multiplying by 5 at the beginning. So I'm going to rewrite this as x squared minus 18x, and 5 times 9 is positive 45. This I can factor into a binomial times a binomial. It's going to have an x and an x at the beginning, and these two numbers, when they multiply together, equal 45. So 1 times 45, make a list of factors, use your calculator. 2 won't go evenly, 3 times 15, 4 won't go evenly, 5 times 9, 6 won't go evenly, 7 won't go evenly, 8 won't go evenly, and 9's already been used. So I've got 3 choices. I want an 18. Which one's going to give me the 18? Check carefully, because this gave me 14. This one gave me the 18. I need to add them, and I want a negative, so I think negative 3 and negative 15, if I add them together, will give me a negative 18. Bad guys and bad guys, yep. If I multiply 2 negatives together, I get a positive 45, so that is true. Minus 3 and minus 15. All right, am I done? No, I have to divide by 5. So divide this piece by 5, divide that piece by 5, put these fractions in the calculator, see if they reduce. This one does not reduce, so the 5 goes in front of the x, and this becomes 5x minus 3 as one factor. And then negative 15 over 5 does reduce down to a negative 3, so this is x minus 3. So those are my 2 factors. If you multiply together, you get that answer. Last one, again, factor this thing, no multiple choice, so I can't multiply the answers together. You need to be able to factor by hand in case they ask you for a single factor. So I look for GCF. Are there x's in all 3 pieces? Nope. I have a 6 and a 37 and a 6. So is there anything that will go evenly into 6 and 37? I don't think so. 2 will go into 6, but it won't go into 37. 3 will go into 6, but it won't go evenly into 37. 6 will go into 6 evenly, but it won't go evenly into 37. So nope, there's no GCF, but you checked. So I want to factor this into a binomial times a binomial, but I cannot do it with a 6 here. So move it to the end with our slide and divide, which means at the end, I'm going to divide by 6. All right, made myself a note so I don't forget. Rewrite this, x squared plus 37x, and 6 times 6 is positive, 36. There we go. So this is going to factor into a binomial times a binomial. It's going to have an x and an x at the beginning, and then I make a list of factors because these two multiply to give me a 36. 1 times 36, 2 times 18, 3 times 9. Did I say that right? Oh, that's 3 times 12. 3 times 12, 4 times 9. 5 won't go evenly, 6 times 6, and I think that's it. But I want a 37, so which one's going to give me the 37? Yep, you're right, this one right here, the very first one. Which means I want positive 37, so I think they both need to be positive to get me a positive 37 when you add them. Perfect. When I multiply them, I have a positive 36. Is that what I want? Yep. So x plus 1 and x plus 36. Am I done? No, we have to divide by 6. So divide by 6 and divide by 6. Put these fractions in the calculator. 1/6 stays 1/6. So put the 6 in front of the x. That is one factor. 36 divided by 6 is a positive 6, so this is x plus 6. So these are the 2 factors that if you multiply together, you get that answer up there. There you go. You should be experts and ready for the test tomorrow. Good luck. Make sure you take that test tomorrow. This is going to go on this 6 weeks. So I'll put a big note on that on Canvas for tomorrow, but you guys need to take that test on Thursday before the deadline for the 6 weeks. Otherwise, you'll have a 0 as a test grade and bring your grade down, and you don't want that.